Welcome to the Funtastic Academy. With me, Ayush Prasad. Hello everyone. Welcome to the Funtastic Academy with me, Ayush Prasad. Today's video, we are going to talk about electromagnets and their applications in many fields of life. But before we get there, let's talk about last episode's quiz question. The quiz question from last episode was, what prize did William Röntgen receive for his pioneering work in X-rays? The answer is the Nobel Prize in Physics. This isn't any Nobel Prize. This was the 1901 inaugural edition. So, pretty interesting, right? Now, let's talk about electromagnets and Faraday's law of induction. As you must know from watching these videos, Michael Faraday was an English physicist whose mark was left all over science. We touched upon him while discussing electrolysis and more recently while discussing the origin of electromagnetic theory. But his most famous achievement was the discovery of electromagnets. Now, Faraday discovered that very strange things happen when you coil wire around a piece of metal. Now, if you put current through this wire, and any random old piece of metal will suddenly turn into a magnet. And the more coils you add, the more stronger the magnetic field. Later, American Joseph Henry built upon this by insulating the wire to create some of the most powerful electromagnets of the time. Faraday discovered a second thing. If you take a real magnet and you coil wire around it, when you start spinning the magnet, current starts flowing. And the more coils you add, the more powerful the current. These two facts are known collectively as Faraday's law of induction. To see why this is the case, let's look at Maxwell's laws. So, you see these four simple laws, they define all of electromagnetic theory. We need to focus on the last two. Now, how does simply coiling wire around metal turn it into a magnet? We need to refer to the Ampere's law. This law states that the curl of a magnetic field is equal to the current of that point plus some other stuff that we not important in our situation. Essentially, what this says is that if you have a current, this will cause a magnetic field to arise. Now, the second part, where a spinning magnet creates power, is described in Maxwell and Faraday's law. This part states that if you have a changing magnetic field, the electric field will curl. In this case, the coil of wire was allowing the field to curl around it and forcing electrons to move, creating a current. Now that we know how electromagnets work, we can see their applications in your everyday life. Now, a simple application of these electromagnetic principles is Lenz's law. Now, in any science museum, you can find a simple exhibit which showcases Lenz's law. You can see it right over here. This disc appears to jump when I press this knob. How does it work? Well, it relates to my upcoming video along an arched path. How come? This is an application of Lenz's law. Let's see in a more familiar context. You have a copper tube and you drop a magnet through it. If this was an iron tube, the magnet would just stick to the sides. But copper is not magnetic. The magnet should just fall like normal. But it doesn't. It falls way slower than it should. How come? Well, when the magnet falls, the copper acts like a coil of wire and a current is produced in the copper which curls around. This is a simple electromagnetic principle. However, the same principle states that when the tube experiences this current, a magnetic field should be formed. And it is. And this magnetic field points in the exact opposite direction to the direction the magnet is falling. This is called diamagnetism. And it is because of this that the magnet is slowed down. This is called Lenz's law. When a moving magnet induces a diamagnetic current in a piece of metal, pushing it the other direction. The same principle is at work with our moving bobbin. Lenz's law is simply creating a force with alternating current to push it along the track. Now, another everyday application of electromagnetism is the transformer. Now, do you use electricity in your house? Well, it would be weird if you say no, because then how are you watching this video? Now, all the electricity in your house likely came from a transformer. You see, in power plants, huge amounts of voltages are produced, which use the transformer to become even higher voltages. They then travel to your house where again another transformer makes some smaller voltages which don't blow up every light bulb in your house. But how do transformers work? Quite simply, they are just an O of metal. Now, there's a coil of wire on both sides of the transformer. There are two types of transformer, a step up and a step down. In a step up, only a few amounts of wire are going on one end of the O and many more on the other. Power goes in to the end where there are few turns, and this creates a magnetic force in the transformer O-ring. Now, sometimes, due to Lenz's law, a bit of this magnetic field's energy will be lost in what are known as eddy currents. But most of it will reach the other side, at which point it will go through all these gigantic number of coils to create a gigantic amount of electricity. And voila, you have conjured up voltage. A step-down transformer works in the reverse way. Electricity comes from the end where there are many coils and goes out from the end where there are few. And that is how transformers work. So, now let's take a quick recap of what we have learned. We have learned about Faraday's law of induction, how electromagnets work, Lenz's law, and the real-life application of transformers. So, I leave you with this quiz question. When I was talking about Lenz's law, I showed you a common science museum exhibit. On the topic of science museum exhibits, which was the first science museum to ever open in India? Tell me the answer, and I'll see you in the next episode of Funtastic,